All right, welcome back to The Explainer. Today, we are diving into a really wild journey. We're looking at how the discipline of legal engineering literally architected the foundations of our modern digital world. If you've ever thought that the rigorous world of contract law and the cutting-edge realm of computer science exist in two completely separate universes, well, prepare to have your mind entirely blown. The tech you use every single day, it was actually built on a centuries-old legal blueprint. Just think about this for a second. How exactly did a centuries-old legal doctrine build the blockchain? It sounds like a riddle, doesn't it? But this is our main detective story for today. The core foundation of decentralized technology isn't just about complex math and cryptography, it's deeply rooted in a concept that predates the printing press. Let's unravel this mystery together.
Okay, let's dive into this. Section 1, the calculus of law, shifting the legal mindset. To really get this evolution, we have to bridge the structural logic of a legal mind directly into the syntax of computer programming. For generations, traditional lawyers have looked at drafting legal documents as creating static pieces of paper. You know, the ink dries, it's signed, and it just sits dormant in a filing cabinet somewhere. But the new calculus mindset forces a total pivot to what we call a runtime perspective. You're no longer just writing dead words. You are building an active, dynamic, executable system. And this comparison hits the nail right on the head. In traditional contract law, a performance means fulfilling your contractual obligations. In computer science, a runtime is the start-to-finish execution of programmatic instructions. They are practically identical concepts. It's kind of like a stage performance or a piece of music. You design the system, the verses and the looping choruses, beforehand. You hit play, and you just watch the performance execute autonomously from start to finish. So if you're coming from a legal background, here is the really empowering part. You already excel at logic. The transition to computer science is largely just a grammatical hurdle. It's a syntax shift. For instance, instead of reading natural English from left to right, you just train your brain to read variable assignments from right to left. That is literally one of the primary mental shifts required to understand the code that now runs our world. Which brings us to Section 2, the smart contract problem, the decentralized dilemma. As brilliant computer scientists were trying to build out early distributed networks, they ran into a massive roadblock of human behavior and economics. I mean, think about it. Why would a global network of independent computers spend their own expensive electricity and computational energy running your code for absolutely free? Well, the short answer is they wouldn't. Without a built-in incentive, a distributed database made up of peer nodes simply won't execute your runtime. The whole system just halts before it even begins. So how do we solve that? Section 3, Hardcoding Legal Consideration, Nick Szabo's translation. Enter the brilliant Nick Szabo, a total game changer. He looked at this massive roadblock in decentralized networks and realized the solution was literally hiding in traditional contract law. He systematically translated the elements of a traditional contract directly into code. But his absolute genius focus was on the legal requirement of consideration, the quid pro quo. He realized to actually incentivize these decentralized network validators, he had to take this exact legal concept of consideration and hardcode it right into the network. And here is the absolute aha moment from the source material. It cuts right to the chase. For a computer to run processes, it actually has to get paid. It sounds so simple in hindsight, doesn't it? But it was entirely revolutionary at the time. To get independent machines to participate and validate a network, they quite literally require digital payment. Look at the direct, one-to-one comparison we have here. What lawyers have historically called legal consideration, the payment or exchange of value binding a contract, is literally the exact same thing as modern blockchain gas fees. Szabo took the legal doctrine of consideration and hard-coded it into the programming language to incentivize the network validators. That is what actually makes the blockchain function. Let's look at how this plays out. Section 4, Incentivizing Decentralized Validators, the mechanics in action. We know the theory now, but let's walk through the exact life cycle of a smart contract runtime to see how this hard-coded consideration actually functions in the real world. Step 1, your executable code is submitted to the network. Step 2, peer validators around the world step in to verify that transaction. Step 3, and this is absolutely crucial, those validators receive that digitized consideration, the gas fees, as their incentive for burning computing power. Step 4. Only then does the distributed database update. This hard-coded incentive structure guarantees network execution. The really wild part is how this fundamentally shifts the architecture of the internet as we know it. By adding this consideration layer, we're replacing traditional REST calls with remote procedure calls, or RPCs. This literally creates actual market dynamics inside our servers. It empowers equal peer-to-peer nodes like the Ethereum virtual machine and treats these smart contracts purely as modular JSON objects. It's what allows distributed databases to function reliably on a global scale.
All right, let's zoom back out. Section 5, the future of automated law, moving from paper to code. Looking at the macro evolution of the legal profession, we are actively moving away from static paper and transitioning entirely into executable code. Think about it like transportation. The 19th century analog era of direct law was like a horse and buggy. It got you there, but it was manual and slow. Our current era of mechanized law, with its hyper-speed drafting but desperate need for new regulatory guardrails, is like driving cars. But the future? That is automated law. These are the Waymos of the legal world. Completely autonomous, self-executing systems that run without a human constantly holding the steering wheel.
To ensure these futuristic legal tools don't just break down, legal engineers are applying the 1980s Unix philosophy, which states text as the universal interface. By writing modular programs that do one thing perfectly and communicate strictly via text streams, we are future-proofing our legal tools. This modular text stream approach is the ultimate foundation for building modern AI chatbots and incredibly clean JSON-based legal records.
And that modular foundation leads us right here, Ricardian contracts. First envisioned by Ian Gregg way back in 1996, a Ricardian contract forms a legal agreement in a format that is both machine-readable software and text-readable for human lawyers. We are finally achieving Gregg's vision today by chaining these modular, permissionless agreements together as software dependencies. If a prerequisite payment breaks, the downstream permission chain immediately collapses with it. It is incredibly precise. So what does this actually mean for the future of the profession? We're looking at two diverging, yet totally interconnected career paths. On one side, developers will increasingly act as specialized legal authorities. On the other, traditional lawyers will naturally begin operating with programming syntax. Why? Because the very nature of legal deliverables is evolving entirely into software. Understanding this modularity isn't just a neat trick. It is becoming a strict necessity for handling complex, automated deals. Which brings us to the end of our journey today. I want to leave you with this provocative question. As legal deliverables evolve entirely into software, how will you adapt to the new calculus of law? Are you going to learn the syntax and help architect the Waymos of the future? Or will you be left trying to draft paper for a horse and buggy? Thank you so much for joining me on this explainer. Keep questioning, keep learning, and I'll catch you next time.